Hello, I am Jay Healy, the head instructor of Lee's Science Academy. Welcome to Lee's Science Academy, a study room where you don't just memorize, but understand systematically and logically through the whole picture. This channel delivers basic knowledge of natural sciences logically and systematically, and it also systematically delivers the mathematics necessary for studying science. Here is today's lecture content. Among the 3 representative operation rules applied to the 4 basic operations of natural numbers, we have studied the commutative law and the associative law up to the last session. Today, lastly, we will study the distributive law. And when various operations are mixed in actual calculations, we will also look at the order of operations, which dictates the sequence in which operations should be performed. Before defining the distributive law, let's examine the form and conditions of operations where the distributive law is defined. The distributive law is defined by combining 2 operations, so 2 operations must first be defined. Having 2 operations is a necessary condition for the distributive law to be defined. To define the distributive law generally, we will represent the operation symbols of the 2 operations as a triangle and an inverted triangle, respectively. When 3 elements of a given set, A, B, and C, are combined with the 2 operations in the following form, the distributive law can be defined. Among the 2 given operations, we determine which operation to perform first. Since there are 2 operations, there are 2 cases. These are the cases of performing the triangle operation first and performing the inverted triangle operation first. The operation performed first is sometimes distinguished as the first operation, and the remaining operation as the second operation. After performing the first operation, we perform the remaining operation, and there are 2 cases here as well. These are the cases of performing the first operation's result on the remaining operation and performing the remaining operation on the first operation's result. Depending on the position of the second operation, it is divided into a left distributive expression and a right distributive expression. If the commutative law holds in the second operation, the left distributive expression and the right distributive expression become the same expression. You understand, right? This time, let's learn about the rules for operating on distributive expressions represented like this. We are given a left distributive expression and a right distributive expression where the first operation is the inverted triangle operation and the second operation is the triangle operation. The operation of a distributive expression first operates the second operation with each number that has undergone the first operation. Applying this rule to the left distributive expression, we perform the triangle operation on A and B, and also on A and C. Then we execute the first operation, the inverted triangle operation, on the results of the 2 operations. Did you understand? Let's apply the operation rules to the right distributive expression. At this time, since we do not know whether the commutative law holds for the operations, we must strictly follow the order of operations. Applying the rules, we perform the triangle operation on B and A, and also on C and A. Then, we execute the first operation, the inverted triangle operation, on the results of the 2 operations. This time, let's practice with a left distributive expression and a right distributive expression where the first operation is the triangle operation and the second operation is the inverted triangle operation. Since the operation of a distributive expression must operate the second operation with each number that has undergone the first operation, in the left distributive expression, we perform the inverted triangle operation on A and B and also on A and C. Then we execute the first operation, the triangle operation, on the results of the two operations. Let's apply the operation rules to the right distributive expression as well. Applying the rules, we perform the inverted triangle operation on B and A, and also on C and A. Then, we execute the first operation, the triangle operation, on the results of the two operations. Did you understand the operation rules for distributive expressions well? If the commutative law holds in the second operation, you can confirm that the operation result is the same for the left and right distributive expressions. Also, since the second operation functions to distribute, it is called the distributive operation. And the first operation connects, so it is sometimes distinguished as the associative operation. Since we understood the form of the distributive expression and the operation rules of the distributive expression, now let's define the distributive law. The distributive law is defined to be established when the operation value of the given expression and the operation value of the distributed expression are equal. In this case, the operations of both the left distributive expression and the right distributive expression must hold. Therefore, for the distributive law to hold, the commutative law of the second operation, the distributive operation, must hold. In other words, if the commutative law of the distributive operation does not hold, the distributive law does not hold. Did you understand the definition and necessary conditions well? The name of the distributive law is called based on the distributing operation. Applying this to the operations given above, when the associative operation is the inverted triangle operation, and the distributive operation is the triangle operation, it becomes the distributive law of the triangle operation over the inverted triangle operation. When the associative operation is the triangle operation, and the distributive operation is the inverted triangle operation, it becomes the distributive law of the inverted triangle operation over the triangle operation. If we call the inverted triangle operation the addition operation and the triangle operation the multiplication operation, the distributive law of multiplication over addition holds, but the distributive law of addition over multiplication does not hold and is not defined. From now on, let's learn about the distributive law in the set of natural numbers. When the two operations in the set of natural numbers are the addition operation and the multiplication operation, let's see if the distributive law holds between the two operations. Before proving it deductively, let's verify it with an example inductively. First, the case where the associative operation is multiplication and the distributive operation is addition. If the three numbers to be operated on are 3, 4, 5, the distributive expression becomes 3 plus the quantity 4 times 5. The value of this operation is 23. Also, the operation value applying the distributive rule to the distributive expression is the quantity 3 plus 4 times the quantity 3 plus 5, which equals 56. This becomes a counterexample where the distributive law does not hold. This time, the case where the associative operation is addition and the distributive operation is multiplication. In this case, the operation result with the left distributive expression is the same as 26, so we can see that the distribution of the left distributive expression holds. Also, since the commutative law of multiplication, which is the distributive operation, holds, the right distributive expression also holds. Therefore, we can see that the distributive law of multiplication over addition holds. Since the commutative law holds for both the addition operation and the multiplication operation, both operations can be distributed operations. But we can see that while the distribution of the multiplication operation holds, the distribution of the addition operation does not hold. This distributive law has multiplication as the distributed operation and addition as the operation receiving the distribution, so it is the distributive law of multiplication over addition. This is the expression of the distributive law for any three natural numbers, a, b, c. You can easily recognize the forms of the left distributive expression and the right distributive expression. From now on, we will deductively prove the distributive law of multiplication over addition that we verified inductively. I will prove the distributive law of multiplication over addition in natural number operations. We must prove both the left and right distributive expressions, but since the commutative law of multiplication holds, I will only prove the left distributive expression. This is the operation expression of the distributive law for the left distributive expression for any three natural numbers, a, b, c. This expression is the one we must prove here. Let's do the proof. Let's set the universal set, where the operation takes place, U, as the set of natural numbers. Let's designate arbitrary three natural numbers as a, b, c. Then a, b, c can be rewritten as the sum of ones, but we will represent them by components without the plus sign. A has a number of ones. B has B number of ones. And C has C number of ones. You understood, right? First, I will set B plus C as D. Then, since the operation is closed, D becomes a natural number. I will do the proof by deriving the right side from the left side. The left side can be written as AD. We rewrite the left side AD according to the definition of multiplication as the repeated addition of the component A, D times. For convenience, the adding notation will be vertical, not horizontal. The component with a number of ones is repeated D times. The meaning of this operation expression is to add all the ones inside the expression. Here we will divide it into two groups to add. One group is added B times. We group the rest into another group, and this group is added C times. You understood, right? You understood, right? Then again, by the definition of multiplication, the first group can be written as AB, which is A added B times repeatedly, and the second group can be written as AC in the same way. Since we have to add the two groups, performing the addition operation makes it the right side. Therefore, the proof is concluded. How is it? How is it? Did you understand well? Did you understand well? We accept and use it as something completely obvious, but I hope you verify the rationale through proof here once. So far we have proven all three operation rules. By applying the rules of operations, let's look at the order of operations, which tells us in what order we can perform operations. First, when addition and multiplication are present independently. Since both the commutative and associative laws hold for addition and multiplication, when they are not mixed with other operations and stand alone, the person calculating can freely determine the order of calculation, regardless of the order written in the equation. Therefore, parentheses determining the priority of operations are not needed, and you just need to list the numbers to be operated on. Doing this allows you to calculate very easily and comfortably. When adding from 1 to 10, the order of writing the numbers does not matter and can be written any way, and the order of calculation also does not matter regardless of the written order. Multiplication is also the same because the commutative and associative laws hold. Please understand here that the reason we usually calculate so easily is because the commutative and associative laws hold. Then, when addition and multiplication are mixed together, which operation should be calculated first? As you well know, multiplication is calculated first, and addition is calculated later. This is not based on a special logical rationale, but an agreement made in advance to avoid confusion. As you can see in the given expression, if you calculate the multiplication first, only addition remains. If there is a special case where addition must be calculated before multiplication, you must use parentheses to indicate the priority. It is agreed that operations inside parentheses in an equation are calculated preferentially first. For example, if you calculate the parentheses first in the given expression, it becomes a case where addition and multiplication stand alone or are mixed, so you can perform the operations in the order of multiplication and addition. Since subtraction and division are inverse operations of addition and multiplication, if they are closed operations for natural numbers, you can operate them like addition or multiplication. This is the main content of today's lecture. Today, we studied the general form and operation rules of the distributive expression and learned how to determine the name of the distributive law when it holds. We deductively proved that the distributive law of multiplication over addition of natural numbers holds. We also explained the priority that parentheses have when determining the order of operations, and examined how the commutative and associative laws make operations easier and faster. Through 3 videos up to today, we have studied the commutative law, associative law, and distributive law contained in the 4 basic operations of natural numbers. These laws apply not only to the set of natural numbers but also to the sets of integers and real numbers that we will learn next, and they apply not only to numbers but also to other mathematical objects like vectors or complex numbers, so you must learn them well. Next time, we will expand natural numbers to complete the integers. This concludes today's lecture. Thank you.